On the 6th of April, 1917, President Woodrow Wilson stood before a joint session of Congress and declared war on Germany. America possessed 55 military aircraft. Germany fielded 2,500. But the numerical disadvantage was only the beginning of the crisis facing the nation's aviation program. The deeper problem revealed itself within hours. Every magneto in every American aircraft engine came from Germany. Robert Bosch, GmbH of Stuttgart, controlled 95% of global magneto production. Their patents covered every viable manufacturing method. Their expertise represented 30 years of refinement. Their magnetos powered German bombers, French fighters, British reconnaissance aircraft, and every American engine capable of flight. The war declaration didn't just create a production challenge, it severed the supply completely. America needed 2 million magnetos within 18 months. Current domestic production capacity: 0. The mathematics were brutal. Aviation programs required 50,000 engines by December 1918. Each engine needed 2 magnetos. Metal fatigue and combat damage meant replacement rates of 40%. The total requirement, 140,000 magnetos, then another 1.8 million for projected 1919 operations. Bosch held the patents. Bosch employed the skilled workers. Bosch operated the precision tooling. And Bosch was the enemy. Aircraft engines of 1917 operated through controlled explosions occurring thousands of times per minute. The magneto generated the electrical spark igniting each explosion. Temperature cycling from -40 degrees Fahrenheit at altitude to 2,000 degrees Fahrenheit in the combustion chamber. Vibration from propeller harmonics. Magnetic field degradation, moisture infiltration, carbon fouling. Any failure meant engine stoppage, and engine stoppage at 10,000 feet meant death. The component required metallurgical precision, electromagnetic engineering, and manufacturing expertise concentrated almost entirely in Stuttgart. Vincent Bendix was born in Moline, Illinois, in 1881, the son of a Methodist minister. His first career wasn't engineering, it was bicycle racing. He competed professionally across the Midwest, winning regional championships before a crash in 1899 left him with injuries that ended his racing career at 18. If he couldn't race, perhaps he could improve the machines. He apprenticed with a carriage maker, learned metalworking, and by 1907 had developed an automatic starter mechanism for motor cars. The Bendix starter drive used a helical gear that engaged during cranking and disengaged automatically when the engine fired, eliminating the dangerous hand crank that broke arms and killed drivers when engines backfired. He founded the Bendix Company in 1910, licensing his starter design to automobile manufacturers. Ford adopted it in 1912. By 1914, every major American car maker used Bendix starters. But Vincent Bendix didn't own the Bendix Company. Investors did. Business conflicts forced him out in 1912. Legal restrictions prevented him from using his own name for 7 years. He started the Eclipse Machine Company instead, manufacturing carburetors and small engine components whilst waiting for the legal clock to expire. The magneto problem intrigued him for commercial reasons long before the war. Robert Bosch magnetos cost $47 each in 1914, a fortune when complete engines sold for $800. Bendix believed he could manufacture them for $12. The engineering challenge lay in the armature, the rotating core generating the magnetic field. Bosch used laminated steel with precise air gaps and wound copper coils requiring 127 separate manufacturing operations. Bendix developed a simplified armature using die-cast components and automated winding machines. His magneto used 31 operations. Testing in 1916 showed 2,000-hour service life compared to Bosch's 1,800 hours. Manufacturing cost, $11.40. The Eclipse magneto won contracts with tractor manufacturers and stationary engine builders. Agricultural equipment makers appreciated the reduced cost. But aviation remained dominated by Bosch. Then came April 1917, and suddenly cost wasn't the consideration. Availability was. The Army Signal Corps, responsible for aviation, issued specifications in May 1917 for the Liberty engine, a standardized 400-horsepower V-12 designed to power America's air war. The program called for 22,500 engines by June 1919. Each needed 2 magnetos, meeting brutal specifications. 100 hours continuous operation at maximum RPM without failure. Operation from -50 degrees Fahrenheit to +160 degrees Fahrenheit ambient temperature, resistance to 15 G vibration loads, and electromagnetic output variance under 2% across the operational range. The Signal Corps invited bids. Vincent Bendix claimed he could deliver 50,000 magnetos by December 1918. Military officials were skeptical. Eclipse Machine Company produced 200 magnetos per day in a facility employing 140 workers. Scaling to 8,000 per day meant a 40-fold increase in 6 months. Bendix showed them his die casting process, his automated winding machines, his simplified assembly sequence. He explained that Bosch manufacturing relied on skilled craftsmen performing hundreds of hand operations. His system used semi-skilled workers performing standardized tasks. Where Bosch needed machinists with 5 years' experience, Bendix needed machine operators with 5 days' training. The War Department awarded a development contract in June 1917. Produce 500 test magnetos meeting specifications within 60 days. Bendix began hiring. July brought 400 new workers. August added 600 more. By September, Eclipse employed 2,100 people in a factory that housed 144 months earlier. The workforce was 67% women. Farm girls from downstate Illinois, daughters of Chicago meat packers, immigrants who'd never touched a machine tool. Bendix told them, "This will keep a pilot alive." The work was brutal. Die casting operations ran at 2,000 degrees Fahrenheit. Winding machines operated 16 hours a day. Copper wire deliveries arrived daily by the ton. Workers assembled magnetos in 12-hour shifts, 6 days a week. Margaret Kowalski, 23 years old, formerly a seamstress, operated a coil winding machine. "We wound 600 coils per shift. The wire cut your fingers through the gloves, but you thought about pilots over France, and you wound faster." Production scaling followed exponential curves. January 1918, 47,000 magnetos. March, 183,000. June, 524,000. The Eclipse factory in South Bend, Indiana, consumed 12% of America's copper wire production. 3 shifts ran continuously. Tooling wore out and was replaced whilst still warm. Rejected magnetos went to the scrap pile at rates of 8%, then 6%, then 3.2% as workers gained proficiency. Bendix walked the factory floor constantly, watching assembly sequences, timing operations, eliminating bottlenecks. Military qualification testing occurred in August 1918 at McCook Field, Dayton, Ohio. The specification required 100 hours of continuous operation at maximum load whilst subjected to temperature cycling and vibration. 3 manufacturers submitted magnetos. Eclipse, a consortium of automobile makers producing Bosch pattern magnetos under license from the alien property custodian, and a French manufacturer hoping for American contracts. The French magneto failed after 34 hours when insulation degraded. The Bosch pattern magneto managed 71 hours before electromagnetic output fell below specifications. The laminated armature had shifted under vibration. The Eclipse magneto ran for 100 hours, then kept running. Test engineers let it continue. At 200 hours, performance remained within 1.5% of initial output. They shut it down and disassembled it. Bearing wear, minimal. Insulation, intact. Coil resistance, unchanged. The results weren't close. The War Department issued Contract W535-AC-8847 on September 12, 1918. 2 million magnetos at $12.10 per unit, delivery by June 1920. The contract value exceeded $24 million, making Eclipse Machine Company one of America's largest military suppliers overnight. But the validation that mattered came from combat, not contracts. Lieutenant Eddie Rickenbacker flew a Spad S-13 fighter powered by a Hispano-Suiza engine equipped with Eclipse magnetos over the Meuse-Argonne sector in October 1918. His combat report from October 27th noted, engaged 7 Fokker D-7s at 18,000 feet. Engine performed flawlessly throughout 40-minute engagement, including 6 separate dogfights and multiple full-throttle climbs. No misfiring, no performance degradation. Maintenance logs from the 94th Aero Squadron showed the story in numbers. Aircraft equipped with Bosch magnetos required replacement every 47 flight hours on average. Aircraft equipped with Eclipse magnetos averaged 186 hours between replacements. Operational readiness rates shifted from 64% to 89%. Zero combat losses attributed to magneto failure occurred in squadrons flying Eclipse-equipped engines. The Germans noticed. Captured Eclipse magnetos reached German technical intelligence in November 1918. Translated documents from the Inspection der Fliegertruppen acknowledged, American magneto demonstrates superior manufacturing efficiency and comparable performance to Bosch model 1917. Simplified construction permits rapid production unsuitable to our manufacturing methods. Our attempts at replication require tooling unavailable in current conditions. They faced an impossible situation. Bosch factories had been bombed repeatedly. The Feuerbach plant outside Stuttgart suffered damage in raids during August 1918, reducing output by 40%. Skilled workers had been conscripted. Copper supplies had been diverted to artillery shell band production. The precision grinding machines necessary for laminated armature manufacture couldn't be imported from Switzerland. The British blockade prevented it. Even if German engineers could copy the Eclipse design, implementing die-cast production required industrial capacity Germany no longer possessed. The window for catching up had closed. The irony was profound. The Royal Air Force and United States Army Air Service had devoted enormous resources to strategic bombing of German manufacturing centers. Raids against Bosch facilities in 1918 cost 47 bomber crew lives. Feuerbach, Bamberg, and Stuttgart plants all suffered damage. Production declined. But stockpiles, imports through neutral nations, and substitution with lower quality components prevented complete collapse of German aviation. The bombing campaign achieved tactical disruption, not strategic destruction. Whilst British and American bombers died trying to eliminate German magneto production, American factories produced superior alternatives in unlimited quantities. The 524,000 magnetos manufactured in June 1918 exceeded total German production for the entire year. Eclipse workers in South Bend, Indiana, farm girls and immigrant laborers who'd never seen an aircraft, outproduced the skilled craftsmen of Stuttgart by ratios approaching 10-1. The campaign to destroy enemy manufacturing capability had succeeded, but not through bombing. It succeeded through innovation making enemy capability irrelevant. Vincent Bendix died in 1945, having built Eclipse Machine Company into Bendix Aviation Corporation, a conglomerate producing everything from carburetors to aerospace systems. The company employed 47,000 workers across 14 facilities. Post-war magneto production continued for aircraft, automobiles, tractors, and industrial engines. By 1960, Bendix magnetos powered 78% of American aircraft. The simplified armature design Bendix developed in 1916 became industry standard. Modern magnetos still use die-cast cores automated winding, and modular assembly. All techniques Bendix pioneered to undercut Robert Bosch's pricing. The company merged with Allied Signal in 1983, then became part of Honeywell International in 1999. Current global magneto production exceeds 12 million units annually. Every general aviation aircraft, every piston engine helicopter, every agricultural aircraft flying today uses magneto technology descended directly from Vincent Bendix's cost reduction exercise developed for the tractor market. The features considered revolutionary in 1918, die-cast armatures, automatic winding, modular replacement, now define minimum acceptable quality. The historical reversal was complete. Germany dominated magneto manufacturing in 1914, controlling 95% of global production through Robert Bosch's patents and manufacturing expertise. 4 years later, America produced magnetos in quantities Germany couldn't approach, using methods German industry couldn't replicate, at costs German manufacturers couldn't match. The nation that entered the war with zero magneto production capacity ended it supplying not only its own forces, but French, British, and Italian aviation programs as well. Robert Bosch GmbH rebuilt after the war, resuming automobile component production in the 1920s. They never regained dominance in aviation magnetos. The die-cast manufacturing revolution Bendix pioneered proved too efficient to compete against using traditional methods. German engineering, despite its prestige and 30-year head start, came in second place. The immigrant bicycle racer from Illinois who'd solved the problem years earlier for entirely commercial reasons, reducing cost, not enabling war, had accidentally built the industrial foundation for American air power. The mathematics of the crisis resolved themselves through innovation, not effort. America didn't outwork Germany. It outdesigned Germany. The 2 million magnetos needed by 1920 seemed impossible in April 1917. By November 1918, Eclipse had delivered 1,400,000, with capacity to produce another million by March 1919. The dependency trap that threatened to ground American aviation before a single combat mission flew became instead a demonstration of what immigrant innovation and industrial scaling could accomplish when necessity demanded it. Vincent Bendix had proved that the critical component everybody depended upon the enemy for could be manufactured better, faster, and cheaper by a former bicycle racer who'd never built an aircraft engine in his life.